average value and RMS value. We can do a calculation of that, so that's a typical example for the
Exam question.
exam.
Is going to be practical part also in the exam?
No.
Only theoretical.
Yeah, doing some calculations. You can say this is
And
practical.
no
but
theory at all.
theory as well. Yeah. Theory may be noise theory.
Yeah, but I have.
Noise,
You have to memorize the equations.
partially.
Well, there
But-
are not so many, I think.
No, they're not.
Yeah, but I have another question, please. The question is, should we also study from the materials from the download area, or only from the notes we take?
In the download area, you got the scripts
And the theory, which will have to learn.
with the theory and all this stuff. But here, it's all for exam. It's only relevant what we did here.
Uh-huh.
So if in the script there's a completely different topic, then you don't have to cover this.
Uh-huh.
But in the scripts there is much more room spent on each chapter. Yeah? So we could not do in the lecture because of the time. Huh?
So, uh-huh.
And what about the book?
Yeah,
That's the
the
script.
book is only
No,
for
not the script. I'm talking about
book
the
in the
book,
lex-
book
the
which
first
you
Yeah.
mentioned at the first session. It's relevant to what you teach, or
Yeah, there's a couple of sensoric books, but too many of them.
so it's better to
And the
read
electronic
the
basics is not relevant for the sensoric lecture. Yeah? But you need them to follow the lecture.
So it's
But you
better
don't have
to
to
read the script instead of the book.
That's super.
Read the script, and if there is something in there you cannot understand, then read these topics in the book.
There's the theory.
Yeah, or ask me. But not at the exam.
And the symposium.
I don't know what to say.
Okay, if you would like to do a
Okay.
practical example, like it
Festival.
might be in the exam,
Festival
What festival?
for Venezuela.
then we can do one. Maybe one I show you how to do, and one you can do on your own. So let's stick to a very simple signal. Actually, the simplest of all, the sawtooth period x peak, and we would like to calculate the average value, huh? Like we were discussing last time. Now we would like to calculate the average value. And here, so first of all, if we would like to calculate the characteristic value of the signal must be periodic. So first check, is it periodic? So what I write down here is just a recipe, just follow the steps.
Okay.
For the exam it will be a periodic signal.
Okay. That's
So it's not that you skip the first part, non-periodic solved.
okay.
Second, what is the period? Here for our example, the period, it might be from one peak value to the next peak value. We don't have zero crossings here because the signal does not have negative values, so there obviously cannot be any zero crossings, so it's from one peak to the next peak. This is the period. Third step, equation. For the average value, who can remember?
The integration of of 1 divided by t, integration of from 0 to t,
Yeah.
x hat, sinus of omega t.
This is not the sinus line.
Okay. X dx.
Exactly. So, what derive the function. So all we need is x from t. Any ideas? This is within our period. Yeah? So the period is the natural border. It's not interested what's happening outside here. The function must cover it only from here to here. Yeah? How can we describe this function? You got a lecture in mathematics. That's
But you can read the
divided delta x. Delta epsilon divided delta x.
Is it the inclination of the
Plus
the
k
equation?
plus t.
So it's delta t 1 minus
just 1 second.
T multiply t plus t. No.
Okay, so what's this?
The slope. No.
Okay, that's the slope here. Huh?
so it's xp till t.
First, we have to see that this is a straight line. Huh? If it's not a straight line, then this is not correct. But you may excuse my drawings, but it's a straight line. Huh? So it's a straight line. Then we got the equation for a straight line is equal to the slope, let's say k, times d plus the offset, d.
0.
The offset here is 0, because it starts right at point 0, 0. So d is 0. If you are not sure about d, then you also can calculate d.
plus d or
And the slope, how can we calculate the
K
slope?
multiplied by
xp
t.
divided by
K.
t.
Yeah, it's delta y by delta x. So no matter where you put this triangle, it gives you always the same value. Yeah? So we can also say, okay, we take the biggest possible triangle. That's, since this is xp, it's xp over our period, and the period is t.
But I don't understand that we have to calculate xt. The
This is the function.
So and we have to calculate that one. Why don't we? Can we use the Pythagoras equation?
You mean square this plus square this is
Yes.
equal to that? This is only the length.
Well, in the
Pythagoras will
equation.
give another function. This is only the length of the hypotenuse. So, this is the slope. This is also the derivation from the function. The first derivation is the slope. xp divided by t. So, our function is xp divided by t times t plus d. D, we knew it is 0. But there might be some other function where you cannot be sure what is d. So the best thing is try to put it on the position t equals to 0. Yeah? T is equal to 0. This is right here. And then our y is 0. So 0 equally to x peak over t times t plus t. T is 0, so e is also 0. Out of this, e equals 0. And now we have our function. So the example is solved. X of t equals xp over t times t plus 0. And now we can fit this into our integral. So 5. Fit it to integral. So it's equal 1 over t, integral 0 to t, xp over 2 times t, dt. The constant here we can put in front of the integral. It's xp hat over t squared times 0 to t dt. Now we can solve the integral. What is the result? T squared half.
xp t.
With the borders from 0 to t. We have to check that we don't have any mistakes in it because it's all recorded. Okay, what's next? We have to fill up our recipe. Solve the integral 7. So what's next?
The result.
We are close to the result, but maybe we have one or two now, one step more. So what do we do with that? This is not a number. Our result has to be a number.
Yeah, it's
We need
t
the
to
period time.
t square, so it be
So we have to
so xp half. xp half.
fit in the borders. Huh?
Yeah, fit in the border, so the result is
Okay.
the result is xp half.
We hat over t 2t squared times t squared minus 0 squared,
That makes 0.
upper border minus lower border,
That makes 0.
so it's 1/2 times xp hat. Is this feasible? So the average value for a linear function seems feasible, that is exactly the half.
The main question is about the we want. The main question is what?
The main question is the average value is given by the measurement instrument if you are measuring that signal on a DC level measurement. Yeah? And this might be the signal of a sensor. Yeah? Maybe the temperature graph within 1 day. So the room is heating up. During the night time it's cooled down, and next day
18.
It goes up. So you see, all it takes to solve the problem is 7 points.
But this is constant, I think.
This is the result is always a number.
Yeah? We'll just take the...
No p allowed in the result, because it's not depending on the period. It must be a fixed number and related to the peak value. Not 3 half. It cannot be bigger than the peak value. The peak value is named peak value because it's the biggest value of the signal. Huh? So every average RMS value must be below the peak value.
Yeah. Half of.
Okay, the next question is calculate the RMS value. Who would like to do that?
I'm recording.
Ah, you are recording. So maybe you can do it. You got the recipe there, just try. And the others will help you. You?
I can do it, but I don't
Yeah.
know. I need help.
You're famous. You're recorded.
Say hello to the camera first.
Okay, so we would like to calculate the RMS value. You can clear up all this here.
You can...
We can go through all these 7 points now and check if we can solve them. Is it periodic? That's the same like in the first question, so you can tick it.
What is the period from the one peak to the other?
Yeah, we still need it's the same because it's the same
Here is
signal.
the same.
Yeah.
The equation.
Now this must be different. Huh?
Yes.
What's the equation of the RMS value?
Square root. Square root 1 over t integral of the function power.
No, first you have to the square.
Square root.
Or you can write RMS squared.
That's 1 over t. 0 to t. X of t squared. X of t. The function. X.
What's x of t?
X. Bracket t.
Oh, x. You call it like that.
So it should be square. X should be square.
X of t
Okay.
is squared.
The square root we calculate this, yeah, x t squared. Yeah.
Because you get and derive the function. So we need
Do we have to do this? No. That's the same. Because it's the same signal, same function.
and then we just go to we have
Calculate the integration.
put in the integration. See? So we just have to solve it.
Yeah. But we have missed the brackets and the squared.
I'm an expert too. I'm also an expert.
Yeah. So you can shift the constant share in front of the integral. Yeah. Is xp a function or? What is xp? It's also constant. It's the peak value. This is just a number. Yeah. Yeah. No, this cannot be true. T squared, the integral of t squared cannot be t squared, huh?
It's times 3. 3. Yeah. 3.
Divided by 3.
T3. T3 divided by 3. The
This
answer
is
is
correct.
T3 divided by 3. Yeah.
So this is 1.
No, this is
No,
t.
Dt is
No, it's T2.
If
so
you're integrating x, what is the result?
x star of 2 divided by 2.
X squared by 2, and if you integrate x squared, then it's
It's
T
t cubed divided by 3.
by 3.
Yeah.
Answer is
t over
T3
3, t
divided
power of
by
3
t raised to the power of 3
over
divided
3.
by 3.
Times
Times.
Everyone is
Times.
talking.
Times.
what?
Take your time.
Divided by 3.
This is the final result.
Yeah.
From 0.
And now we need the borders.
Yeah, from 0 to t. Is equal to?
And now where we are, number 5. Huh? Fit it to the integral we got. 6, solve the integral we also got.
Fit in the borders.
This we still have to do. Huh? Fit in the borders. How do we fit in the borders? It's always upper border minus lower border. So you have to fit in the capital T into T and 0 into T. like we had before.
Yeah. So to t cube, it will be t
The
cube.
result is x hat p times 2, x squared divided by 3.
Yeah, but we still need the way how to get there. Huh?
That's the final answer.
That's one,
It's the
the
final
final answer, yeah, but we are not
But to
there.
fit the border is easy.
Just fit the capital T into
Capital
T
T.
raised to the power of 3 minus the lower border.
Yeah.
Huh?
Yeah.
Minus 0
Yeah.
to the power of 3.
Yeah.
Yeah, but
Yeah.
XP it has.
Yeah. So what's the RMS value? It's the square root out of this.
Yeah.
But for the RMS value, always calculate the square of the RMS value, because otherwise you always have to draw this root
The square root,
all
yeah.
the time.
And integration of the.
Yeah. And after you have the result, then you can get the root. Thanks. Okay, I think there is
Super.
nothing to say with this example.
Okay, will
so
teach me
try
the
another
subject.
one. What's the time?
No,
How many minutes do we have left?
15 minutes.
10 minutes left, then we have
10 minutes,
a
yeah.
simple example.
I will start studying this subject.
I have to
All we do is
make a recap of integrals.
Mm-hmm.
we change the direction.
Yeah, then we have a different value.
Yeah.
Irfan. Go for it, man.
Just RMS or both of them?
If you like to start with the RMS,
So for the RMS, you have to change the.
Yeah, that's why I draw it differently.
No.
Is it periodic?
Periodic. That's the period again from 0 to t.
yeah.
Talking about the equation, so the equation is I think the slope is negative, so it has minus.
Irfan,
Yes.
can you write bigger a little bit?
Bigger than this.
Yeah, please.
Because otherwise you
What?
cannot figure it out on the video.
Yes.
The RMS must plot different from.
Why is it negative?
Because,
the slope is negative.
Yeah.
The slope is negative, so we have xt equal to kt plus d. D is 0 again, so we start.
D
No, no,
zero.
No,
again.
zero is
It's-
not
it's
there.
XP.
Zero is x.
xp.
X is XP. Ah.
Yeah,
X. X or XP?
Without hat.
XP.
X hat. Okay, so
But
I
it's
have a
actually
question.
The same. XP hat is equal to XP.
it's the same.
Yeah, that my question is, what is XP hat?
The peak value.
The peak value.
Normally over
Uh-huh.
the peak value you always put the hat.
Uh-huh. Okay.
But this is a double reference. P and hat.
Uh-huh.
So we can put X hat or XP.
Uh-huh.
And the k factor is it's minus kp.
X, this is minus XP over T. That's why it's negative.
So it's k t. Okay. So right now we can say say that for both of them is the same. So I want to, make it easier. Can I?
Yeah, yeah.
Take XP, yeah, the common.
Everything that is mathematically correct you can do.
-1. -1, yeah.
Like
Yeah.
this, it is okay. So, and fit to the integral. Okay, so
RMS squared.
xt. So
Yeah, this one is for this. Yes, the same like this one. Oh, because I was having this image in my mind. No, this one is this one.
Yeah.
Talk.
right now we can divide it to several integrals. So the first part should be like this. So you can say that okay, xt okay, and also this 0 to t into dt plus okay 1 over t equals integration dt minus 2t2 so it's
Irfan, please bigger.
Bigger. You have to put up.
right now bitte wurde and I can make a factor of xt right now. So it's t2 plus t divided by t minus 2 t2 so it's 2 answer should be xp2 divided by 3.
Yeah, it's correct because it has to be the same line, because it doesn't make any difference if you change the sign of the slope.
Okay, thanks. So you got an idea what kind of practical examples might be during the exam. If you like, we can do other examples
Yeah.
at the end of the lecture.
Yeah, please, it will be great.
Excuse me. It's RMS2. It's RMS2. The result is for RMS to power of 2.
Okay, then I think we close for today. Next time we will discuss a little bit